Alright, so we're starting to get towards the end of the paper, and we know that partly because usually at the end of the paper we have our Euclidean geometry questions. So these are the types of questions that requires a little bit more study than just understanding. So a bit of practice, knowing some of the rules, that makes life a lot easier. So let's just dive into it. Question 8.1 says we have this diagram, and all the information in here in this diagram is just given in the description at the top as well. 8.1.1, so 8.1.1, we have determined with reasons, so that's where so you can't just guess, we have to give reasons. That's why you need to know the rules and the names of the rules. Give the size of angle R. So angle R is this angle right here. And how can we find that? Well, we can see this is a parallelogram. The QRKW, that is a parallelogram, which means that RQ and KW are parallel, as well as QW and RK. So therefore we know that this angle R and this angle Q together must give us 180 because they are co-interior. So we can suggest, all we need to say is angle R equals 80 degrees, and our reason is co-interior angles, or co-interior. That's the key word they're looking for. Then 8.1.2, the size of angle P. So angle P, this one here. Now we can see that angle P is part of PQRS, which makes a cyclic quadrilateral. Now in a cyclic quadrilateral we know that opposite angles in a cyclic quadrilateral are also add up to 180. So we already know what R is 80. We already know this is 80 degrees. So we know that P must be 100. Alright? So angle P equals 100 degrees, and our reason for that is opposite angles in a quadrilateral. Right, opposite angles in quadrilateral, that adds up to 180. So this is fine, that's the name of the rule we're using. Okay, then 8.1.3, PQW, so PQW, this angle here, so Q2. So I think it'll be easier to use Q1 and Q2 for the names as we work this out. Now, we can see that obviously Q2 is just the whole Q, the big angle Q, minus Q1, right? But what is the whole angle Q? Again, we can use this part here. We can say that angle S1, so we'll start with angle S1 is equal to 44 degrees. And why is that? Our reason for that is because it lies on a straight line, and S2 is already 136. So we'll just say angles on a straight line. Angles on a straight line. Straight line. Alright. Then, once we have this angle, we can now see, okay, what will this whole angle be? Because PQRS is a cyclic quadrilateral, so angle S1 plus Q must be 180. So we're going to say the whole Q, so I'm just going to say Q, we can call it, let's call it PQW, PQR, the whole Q. Angle PQR, that is 136, and the reason for that is opposite angles of a quadrilateral again. So opposite angles of a quadrilateral. I'm just going to write quad here. Opposite angles of a quad. And then we can say Q2, which is the one we want, equals the previous one we got, PQR minus Q1. Alright, so that means that Q2 would be equal to 136 minus 100, which gives us 36 degrees. Alright, that's perfect. And then finally question 8.1.4, and then we'll head on to question 8.2 here as well. So 8.1, the last one we'll do is 8.1.4, last question here. So this says to calculate the value of angle U2, that one there. Alright, so a couple of ways we can do this. I think the easiest way would be to use this idea. Right, we know that these two angles are equal because of what? These two lines are parallel. So therefore we can use alternating angles. So we can say U2 equals S2. S2. Which will mean that, and the reason, let's put the reason, alternating angles. Alternating angles. Okay, so that means U2 equals 136 degrees. Perfect, so that's it for question 8.1. And again, there are many different ways we could get to answer. So in the comments, please let me know which methods you used, and let's discuss that. Let's see what is the easiest, what's the longest, what's the shortest, and what's the most thorough. Question 8.2, only 2 questions here. So 8.2.1, 8.2.1. So we have this quadrilateral, this quadrilateral here, and we don't know anything about any of the angles. All we're given is some of the sides. Alright, so we are asked to prove with reasons that EFD, I'm going to write that down, EFD, this angle F, is equal to ECD, that angle C. So EFD, so that's this angle, must prove that's the same as ECD, as this angle. Okay, so I think what I want to do first is I'm going to say that EFD is exactly the same as EFT, right? This triangle. So I'm going to say EFD is I'm just going to write that slightly better. EFD is exactly the same as EFT. Okay? And we're going to do the same for ECD. ECD is the same as TCD. So angle ECD is exactly the same as TCD. And we will use these two triangles because we can see sort of by looking at it that they are similar. 9 to 18 is the same as 5 to 10 and 7 to 14. So we're going to use that idea. We're going to use that idea. So we're going to say that angle yes, let's say let's put it in this order: DCT, this triangle, and triangle EFT. Triangle EFT. Okay, if we compare these two triangles, let's just put a triangle in front to show we're talking about that. Then the ratio of DC to EF, what is that? So DC, where's DC? DC is 18 and EF is 9. So that gives us 2. Let's try with, so that was DC and EF. Now let's try with CT and FT. So CT to FT is, CT is 10 and FT is 5. So 10 to 5, which is also 2. And finally, let's do one more. Let's do DT and ET. So DT to ET, that is DT is 14 and ET is 7. So 14 to 7, that's also 2. So because these ratios are all the same, we know that those triangles are similar. So we can say that means that DCT is similar to EFT. And when triangles are similar, we know that this angle equals that angle, this angle C equals this angle F, and angle T equals angle T. Alright, so we can say therefore angle C, so let's put it as we wanted to show the angle C and angle F, right? So let's say therefore angle DCT equals angle EFT. Because when triangles are similar, all the angles are exactly the same. So there we have it. That is fine. And if you want, you can just convert this back into the original question that had the D's and the e's with it. Alright, but that's fine, we've proven that. So the idea here was just to take these big triangles that they gave us, these big ones, and to make them into smaller triangles where we could see the ratios are the same for the two triangles and they are similar. Right, 8.2.2, 8.2.2. Okay, so I think here we'll have something similar. So we need to prove, let's just write on the question, DFC. We need to prove that DFC, this angle, equals the angle DEC. DEC. Okay, so DFC, so that's this angle here, and DEC, so that's this angle here. We have to prove that these two are equal. Okay, so again, I'm going to use smaller triangles. I'm going to use DET and FCT. I think so. DET and FTC. Yep. So this triangle and this triangle. Okay. So let's again just say, so DET. DEC, that was this one, we're going to change to DET. So DEC is exactly equal to DET. And then we'll use that triangle. And the other one, DFC, that's exactly the same as TFC. So DFC is exactly the same as TFC. And we'll use that one. Okay. Now, I'm just going to zoom out a little bit so we can still see the picture as we're working. So what we want to do now is something similar to the top. So let's just arrange them in the order that we have the similar sides. Okay, so in angle DET, this one. So we know ET. So let's put ET first. Let's put ET and then D. So ETD. Okay, and for the other one, let's put, so which one has the same ratio to 7? So 7 to 5 and 14 to 10 will be the same ratio, right? So 5, so let's put for that one, let's put FT. Okay, let's put FT first and then C last. Alright. So we've got our ratios there, on our triangles at least. So triangle. So we're going to show that these two triangles, again, are congruent. Not congruent, sorry, similar. Big difference, big difference. Okay, I'm just going to change color here and go to, let's say, a pink. So find the ratios of ET to FT. So ET to FT, what does that give us? So ET is 7 and FT is 5. So that's 7 over 5. Alright, and we can also do TD and TC. So TD over TC, what does that give us? TD is 14 and TC is 10. So 14 over 10 simplifies to 7 over 5. Right, so two of the sides are the same ratio. That will mean the third side is in the same ratio. So we can already say that these two triangles are similar. But just to be sure, or just to show it properly, let's just show ET and FT. So ET and FT, these two we've proven are in the same ratio. Then we've shown that TD, so TD and TC are in the same ratio. So that'll mean this side and that side will be in the same ratio. But what else we can do is we can just show, it's slightly different color there. We can show that this angle and that angle are exactly the same, right? Because they're opposite angles. So we know they're the same, and therefore we've got a side angle side. Now usually we use side angle side for congruency, but we can also, it works the same with similarity. Sorry for my words. It works the same with similarity. if we have sides in the same ratio and an equal angle in between, then we do know they are similar. But even the two sides in the same ratio will suffice. Okay, so now we can say therefore these two triangles, the triangle ETD is similar to FTC. And once we have similar triangles, we know these angles are the same. Angle E equals angle F, angle T equals angle T, and angle D equals angle C in these triangles. So we wanted angle F and angle E, so we can say that implies that angle E, let's maybe just switch this up a bit because we need the E and the F. So we can switch the order of the triangles. So we have the E in the middle. So let's just move this one to the front. So we've got D E T is similar to triangle, and then move this one to the front as well, C F T. Alright, and then we've proven these angles, angle E and angle F, are the same. Perfect. So yeah, that is fine. So that those two triangles are similar, which means that angle DEF, if we want to write it properly, is equal, DEF is equal to CFT. CFT. That's it. So that's actually what we want to prove, that these angles are the same, angle E and angle F. Alright, sorry, this was a bit of a lot of mumbling going on in this question, but I hope it still helped. And I didn't go through where any of the rules come from, but hopefully you have all the rules with you and you can study them and just at least see how we use them, even though we didn't derive any of the rules in this video. But join me again for the next question. We're getting towards the end of the exam now.